Hey everybody, welcome to my humble house. Let's go check it out and we're gonna go do some math today. So you can see I have this nice little house here. Let's go downstairs and we're gonna head over to the classroom now. Go outside and here we go. I have this special teleporter. Here we go. And oh, where are we now? Oh look, here's our classroom. Let's go in and say hi to the students. Hi everybody. It's time for math and let's see what we're going to do today. Oh, today we're going to learn about powers and exponents. Let's go look at some examples outside. Come on, field trip. And look, we have this special area here. Oh, what do we have? This says, look what we have. We have a square here made out of blocks. It's 1, 2, 3, 4 by 1, 2, 3, 4. So this is a 4 by 4 square. So we write it as, you can write 4 times 4. You can also write 4 squared, because get it? It makes a square of 4 on each side. 4 by 4. So that's 4 times 4. We call that 4 squared. It's also called 4 to the second power. And here's how you write it. With 4 with a little 2 on the top. That means you multiply itself. The number is multiplied itself 2 times. Got it? So let's look at another one. Here's a smaller square. This says 3 times 3. And if you can see there's 1, 2, 3 by 1, 2, 3. So it's a 3 by 3 square. So we call that 3 squared. And you see I have that 3 little up arrow too. That's like this. 3 with a small 2 on the top. Now, let's break that and let's turn this square, this 3 by 3 square, into a cube. So the way we do that is we're going to build another layer. Great. So now what we have is, instead of a square, we have a cube. And the cube is 3, 1, 2, 3 times 1, 2, 3. So that's 9. But then we have 3 of those layers, right? So we have 3 times 3 times 3. And that would be 3 cubed. So let's see how that's written. 3 times 3 times 3 is the same as 3 to the third power, which is the same as 3 cubed. They call it 3 cubed because you're making a cube. 3 times 3 times 3. So any number to the third power is called cubed, and any number to the second power is called squared. It's just a shortcut that people do. All right, let's go back to the classroom and do a little more education. Oh, look, there's a little bunny. Okay, we'll close the doors. All right, everybody, please stop jumping on the desks. Thank you. We're going to do a little math here. So let's check out this really cool video. Hey, everybody. Welcome to math. We're doing lesson 6.1, which is powers and exponents. Please go to page 433 in your new math book, right? This is volume 2, page 433. You won't be able to find 433 in your old math book. It only exists in your new math book. So please go there, ready, go. Okay, so with powers and exponents, we need to learn a little bit of vocabulary first. So first of all, you need to know, well, you hopefully know that when you have 10 times 10 like this, when anything that you multiply, they're called factors, right? So I want you to fill this in your book too. F-A-C-T-O-R-S, factors. And then when you have this is when you have a number with an exponent. The main number, we call that the base. So in this case, 10 is the base. And the 2 here, the little number on top, that's called the exponent. E-X-P-O-N-E-N-T. And the exponent just tells you how many times you're going to multiply the base by itself. So a 10 to the second power is 10 times 10. If I had 10 to the fourth power, it would be 10 times 10 times 10 times 10, which is a very big number. This would be, well, it's easy because it's times 10. This would be 1, 0, 0, 0, 0. This would be 10,000. So 10 to the fourth power equals 10,000. It is not 10 times 4 equals 40. No, no, no. It is how many times? It's times itself. 10 times 10 times 10 times 10. Got it? Great. Okay, so let's look at an example of an exponent. An example of exponent, if I have, oh, I don't know, 4 to the third power, right? The exponent here is the 3 and the base is the 4. And 4 to the third power just means 4 times 4 times 4. It is not 4 times 3, no. It tells you how many 4s you're multiplying by itself. And in this case, we have 4 times 4, which is 16. Then you have to take that 16. 16 times 4 is going to be, what, 64? Okay, and so a definition of an exponent should be something like it tells you how many times you multiply the base times itself. So here we have a 3, that's the exponent. That tells me that we multiply the base, which is 4, times itself 3 times. So here's an example of a real world link. Here's an MP3 player. This is what iPods used to look like. I don't think they look like this anymore. So they can come in 2 gigabyte, 4 gigabyte, 16 gigabyte sizes, where a GB means gigabyte. 1 gigabyte is equal to 10 times 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 10 bytes. That's a lot of tens. You think there's an easier way to write it? Well, there is. Let's count how many tens there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there are 9 tens. So I write the base, which is 10. And how many of them are there? There's 9. That's how many times it's multiplied by itself. So that is 10 to the 9th power. Sorry if that looks like a lollipop. It's 10 to the 9th power. Now, a special thing just with tens, that also means if I were to multiply that out, 10 to the 9th power means that it's just a 1 with 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that is a lot of zeros. So 10 to the 9th power just means a 1 with 9 zeros after it. That only works with tens. It doesn't work with other numbers. Okay, so now we're on the next page, page 434. And it says here that numbers expressed using exponents are called powers, right? That's the little number on top. That's the power. For example, 100 is a power of 10 because it can be written as 10 to the second power. Numbers like 100 are perfect squares because they're squares of whole numbers, right? And this is sort of what we saw in the Minecraft video, except this one is 10 by 10. It's a square, 10 by 10, so it's called 10 to the second power because it's 10 times itself 2 times and it equals 100. That's also why this is called squared, U-A-R-E-D. So this would be 10 squared. And now look at the orange one. This is 10 times 10 times 10 because we have 10 on the bottom, 10 squares. It's 10 squares tall. So the face of this would be 100, right? 10 times 10. But there's 10 rows or 10 columns of it. So this is 10 times 10 times 10. 10 times 10 times 10. Because there's 3 tens, that's why this is called 10 to the third power, which is also called 10 cubed. Because whenever something is to the third power, it's making a cube out of it, right? And that, of course, this equals 1,000. And now notice this. There's a 3 here. There's 3 10 times 10 times 10. And there's 3 zeros in 1,000. So the number of zero things that, again, only works when it's 10. But you'll see this a lot, especially in science kind of things. Okay, so now let's look down at the bottom half of the page. And so let's look at some examples. Here we have 6 times 6 times 6 times 6. You write that using as an exponent. Well, there's 4 6s, 1, 2, 3, 4. So that's why we write it as 6 to the 4th power. So we call that 6 to the 4th power. Got it? It just means that there's 4 6s. And again, this is not 6 times 4. No, no, no. 6 to the 4th power is a much bigger number. Let's try this one. 4 times 4 times 4. We kind of used an example of that. So in this case, the factor 4 is the base. That means that's the main number, and it's multiplied 3 times, so the exponent will be 3, so it's going to be written as 4 to the third power. Got it? Okay, so you guys should have this pretty well. We did it in class, but just so you know, letter A, we have 7 times 7 times 7 times 7, so you're going to write a 7 because that's the base. How many 7s? 1, 2, 3, 4. That's 7 to the fourth power. Now, right now, we're not making you figure out what that number is. We're just hoping that you can write it out. Now, here's this one is going to be really big, right? We have 9s, right? So it's always 9 is the base. We have 1, 2, 3, 4, 5, 6, 7. So it would be 9 to the 7th power, which will also be a very big number. All right, so now let's go to the next page, which is 435, right? And now you got to figure out what these things actually are. What is the answer? So here they give you an example of 5 to the second power, which is 5 times 5. And you know that 5 times 5 equals 25. So you could write that 5 to the second power, or 5 squared, equals 25. Easy peasy. Now look, sometimes you have to do it with decimals. Isn't that fun? So here I have 1.5 to the third power, which means 1.5 times 1.5 times 1.5, which equals 3.375. And of course, we don't expect you to have that memorized. You'd have to write that out. You can also do it with fractions. So notice how they write this. They write 1/2, they put it in parentheses, to the third power, or cubed. So that means it's going to be 1/2 times 1/2 times 1/2. And of course, you guys remember how you multiply fractions. So you just multiply straight across. So 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. So that's why the answer is 1/8. Easy, right? Okay, so let's try C, D, and E. Got it? So you guys, what is 10 to the 5th power actually equal to? Remember my hint I gave you about the zeros with 10. On your mark, get set, go. Great. So for this, you should know that 10 to the 5th power is 10 times 10 times 10. That's 3 times 10. That's 4 times 10, which is 5. And the shortcut when you have 10 to the 5th power just means it's going to be a 1 with 1, 2, 3, 4, 5 zeros. So which is 100,000. So now you guys try 2.1 to the second power. Ready, go. So 2.1 is going to be 2.1 times 2.1. So you're going to have to multiply that out. And when you get it, it will be 4.41. Cool. Okay, last one of these. Let's try letter E. 1/4 squared, or 1/4 to the second power. Ready, go. All right, so this just means it's 1/4 times, and you'll see this sometimes people write a dot for times. 1/4 times 1/4, which is going to equal 1 times 1 is 1. 4 times 4 is 16. So this will be 1/16. Easy. All right, so now we're on page 437 in your book. We may have done a few of these problems in class. These are super easy. So on the first 6 problems here, they're not even asking you to find out the answer to the problem. They just want you to write it as an exponent. So let's try 6 times 6. How would you write that as a number with an exponent? Ready, go. All right, well, look, there's just 2 6s. So this should be, this should be 6 to the second power, or 6 squared. That's pretty easy, right? Now, how about this? 1 times 1 times 1 times 1. Okay, ready, go. All right, so this is pretty easy. You have 1 to the third power, because it's 1 time, and there's 3 of them, so it's 1 to the third power. That's pretty easy. Notice they're not asking you to figure out what is 1 to the third power. I'll give you a hint, it's 1. Okay, let's try number 3. Ready, go. Okay, so you have 5 times 5. You have 1, 2, 3, 4, 5, 6. You have 6 of them, so you have 5. That's your base, and it is to the 6th power. Easy. All right, let's try number 4. Ready, go. So this is just 12 to the second power, or 12 squared, which, in case you didn't know, is 144, but they're not really asking for that. They just want this part. Okay, now you try number 5. Ready, go. All right, so we have 27, and there's 1, 2, 3, 4 of them, so there's 27 to the 4th power. That's pretty easy, right? And let's try this one. Number 6, ready, go. All right, so you have 15, and there's 3 of them, so it's 15 to the third power. Notice this is not 15 times 3. It is not 15 times 3. It is 15 times 15 times 15, which is a very large number. All right, so now on 7, 8, and 9, they want you to actually multiply it out to find the answer. Got it? So here we have 6 to the 4th power. So that means this is going to be, so you should write it out first, 6 times 6 times 6 times 6. So if you think that this is 6 times 4 is 24, oh, no, 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 that's very wrong. So why don't you go ahead and you can use a calculator and figure out the answer to this. Ready, go. Okay, so let's try using a calculator to figure this out. So here I have, our problem is 6 times 6 times 6 times 6. So I'm going to write 6 times 6 times 6 times 6. And the answer is 1,296. And that's what you should have, 1296. For this one, 1296 is the answer. 1296. Now it's a big multiplication problem. One way you can do this is you can say 6 times 6 is 36, and this 6 times 6 is also 36, and then you can multiply 36 times 36, which is 1,296, or you can just multiply them one at a time. They're both fine. Okay, let's try number 8 the same way. If you need a calculator, go ahead, but see if you can do it without. Ready, go. So the first thing you should have is 0.5 times 0.5 times 0.5. And I know that 5 times 5 is 25, and 25 times 5, I know that is 125, so my answer should be 0.125. And if you use the calculator, that's okay. Now let's try number 9, and this one, you can't really use a calculator, can you? Because it's a fraction. So you try number 9, ready, go. All right, so we have the whole fraction 1/8 times itself. So this is 1/8 times 1/8. That's what this means. Notice it does not mean times 2, it means 1/8 times 1/8. And you know with fractions, you multiply straight across. 1 times 1 is 1. 8 times 8 is 64. So you have 1 over 64. That's pretty easy. Okay, let's just try one more problem. All right, so let's look at number 10 on here. And this is actually really useful information when you work with computers. And maybe that's what you're going to do someday. Here we have a kilobyte, or a K we call it, is 10 to the 3rd bytes, right? A megabyte is 10 to the 6th bytes, and a gigabyte is 10 to the 9th bytes. So here it says a kilobyte is equal to 10 to the 3rd, or 10 cubed bytes, right? 10 cubed as a product of the same factor. That means you're going to have something times something times something, and then find the value. So 10 to the 3rd, write that out. Ready, go. Okay, so you should have 10 times 10 times 10. And then when it says find the value, you're going to now multiply that out. And if you remember the trick I told you with multiplying by tens, you just count the zeros, and that's going to be your answer, right? So the answer should be 1,000, because there are 3 tens and 10 to the 3rd power, 3 zeros. That's easy. So if you could do that, then letter B should be pretty easy too. Ready, go. Oh, okay. So you should have 10 to the 6th power is, oh boy, I got to write 10 of them, right? 10 times, I got to write 6 of them. 10 times 10 times 10, that's 10 to the 3rd power, times 10 4th, times 10, that's 5th power, times 10 6th power. Because there's 1, 2, 3, 4, 5, 6 tens. Now, what is the value of that? And if you remember, it's going to be a 1 with 6. Ready, go. So you have 1 with 1, 2, 3, 4, 5, 6, which is 1,000,000. Whew. Okay, now letter C says, how many more bytes of information are in a gigabyte than in a megabyte? Wow. So a gigabyte is 10 to the 9th power. So that's going to be, we'll do this one together because it's kind of hard. 10 to the 9th, 1, 2, 3. 1, 2, 3, 1, 2, 3. That is 1 billion, right? Gigabyte. And then a megabyte is 10 to the 6th. So that's going to be 1, 2, 3, 1, 2, 3, and a 1 here. And now I have to subtract them, right? Because how many more bytes of information? Oh boy. So these are all going to stay as zeros, right? 0, 0, 0, 0. And now it's really like, what is 1,000 minus 1? Well, that's 999. So your answer is 999 million. Okay. I didn't make you guys do that one because I tried that last year and everybody got stuck on it. All right, so that's all I have to tell you. So let's go back to our classroom. All right, everyone, I hope that you learned something from that. And make sure you answer all the questions, and I will see you in class tomorrow. Bye.